Hello, General Chemistry. Right now, I am sitting at home, drooling likely, because I have just had a root canal. And wait, it gets worse. It's a root canal of a former root canal that didn't work. Woohoo! So, right now I've got probably the whole side of this face numb, and I'm probably drooling and, maybe napping, who knows. Today we're going to learn about the tools of a scientist. All right? So, even though I'm not here, I'm still teaching you, so you still have to pay attention. By now, the substitute has passed out the note sheets, so we're going to fill those out together. First of all, things we will commonly measure. We will measure mass. Mass is the amount of matter in a substance. Volume. Volume is the amount of space a substance takes up. Length is the linear measurement of something from end to end. And temperature is the average kinetic energy of particles, not the heat, because heat takes into consideration both the average kinetic energy and how much you have. Temperature is just that average kinetic energy. All right, so what are my common units? What are the units we use for mass? Well, first of all, I have told this story already. When I was in 6th grade, my 6th grade teacher, Mrs. Birch, told us all that by the time we were adults, the United States would be completely switched over to metric. Okay? Either she lied or I'm not an adult yet. I'm going with the latter. It's interesting because if you go up to Canada, everything's metric. When you go over to the continent, to Europe, everything's metric, except England is still caught in between. I student taught in London, and I would buy my milk in quarts. Yet if I went in to buy cheese, I had to figure out how much of a kilogram of cheese I wanted. The roads were still measured in miles. Yet if I wanted to buy gas, which I didn't have a car, so I never bought gas, but if I wanted to buy gas, it was in liters. And so instead of calculating the miles per gallon that your car got to figure out gas efficiency, you calculated miles per liter. The house I lived in had been remodeled, and they had a set of steps going up, and the last step was a little bit shorter than all the other ones. And that is because when the house was built, they used the English system, feet and inches, and when they rebuilt the house, they used metric, and in order to get all those steps evenly spaced, the last one had to be just a little bit shorter. Okay? So, we use the metric system. Everybody uses the metric system, and we use it in science. So if I catch you guys using a ruler and doing inches, you might get to see my head come off and fly around the room a few times. We don't do that. And you guys have heard this before. You've heard it in grade school. You've heard it in junior high. You should know all this by now. All right. So what units do we use? Well, we have a system that has been put together, and it is over in Paris, in France. It's the international system, or if you were French, you would say Système International, although I'm sure I butchered that French, or the pronunciation at least. Okay? And that is where they have a kilogram mass, and that is the basis for all kilograms. They have a meter-long rod. That is the basis for all meters. And somewhere, of course, liters are volume is calculated, but for volume, if you take length times width times height, and they use that standard meter to calculate that. All right, the SI units, the System International Units. Mass is actually a kilogram. We think it's a gram because that's our base unit, but really a gram is so small, a kilogram is much easier to use. Now, if we're weighing paper clips, we're probably going to use grams. Length is a meter. Time is measured in seconds. Temperature is measured in kelvins. Kelvin is a system just like Celsius, only it has no negative numbers. When we get to gases, we aren't going to want negative numbers. So we will use Kelvin at that time. Once again, if we're measuring temperature in the lab, I need you to be doing Celsius, because Celsius and Kelvin are interchangeable for the most part. There's a step you have to do, but it's not like going Fahrenheit to Celsius. We're not going to use Fahrenheit. The amount of substance is the mole. We'll talk more about that in the spring semester. If we were doing electric currents, amperes, which we already measure in amps, our currents. And if we were talking about light, we would use the candela. Notice, volume's not on here. That's because volume is calculated. It isn't something you can directly measure. It's a calculated number. You have to take length times width times height, or the diameter of a cylinder times its height, so on and so forth. Of course, we're going to measure it directly using a graduated cylinder, but in order to figure out how big the graduated cylinder needed to be, guess what we had to do? We had to calculate it. All right, the prefixes. Some of these prefixes you're not going to see. The basic prefixes, forgot I had my little slate here. The basic prefixes are these four in here: kilo, deci, centa, and milli. Nobody ever uses hecto or deca. It's just not useful. We're going to use centa when we're using length and we have to measure something small. Milli for volume. We use milliliters. You don't usually see centiliters. Although when I was in England, student teaching, 29 years ago, the can of soda said centiliters on it. I guess it's 28 years ago. I'm jumping the gun. This is my 28th year of teaching. Okay. All right. What's the good part about the metric system? Well, they're all based on powers of 10. So it's much easier to calculate. A centa is 10 times bigger than a milli. So you just multiply milli times 10. A kilo is 1,000 times bigger than the base unit. So on and so forth. Now, if we put this scale out, here we can see the common ones that are all separated by 1,000. If we have, this is our base unit. 3 times that, 1,000 times bigger is the kilo. 1,000 times that is mega. Then we get to giga, tera. You guys have heard those prefixes. Okay? Back in the day when I started teaching, we had Apple II GSs in the teacher's, we had one in the teacher's office, and we would buy we had our little discs, and they were measured in kilobytes of memory. And when you go buy one of these guys now, what do you buy it in? Now they're in gigabytes. Okay, they were in kilobytes in the early 90s. Fast forward, the machines got bigger, could hold more information, we went to megabytes. Now we get gigabytes, and you'll hear people talk about terabytes. Each of these is 1,000 times bigger than the one before it. Milli. We already know milli. Micro is 1,000 times smaller than milli. Nanometers or nanoliters or whatever is another 1,000 times smaller, and pico is even smaller than that. Okay, let's talk about making conversions from one to the next. Okay, if I tell you that I have 10 grams, and I want to go from grams to milligrams. Okay, let's say I'm taking medicine, and I need 10 grams of medicine, but I only can measure in milligrams. What I'm going to do is I'm going to go from grams to milligrams. Now, notice we have the nice little stair-step unit. I'm going to count down. I'm going to go down 1 step to deci, 2 steps to centa, 3 steps to milli. So I moved my decimal 3 points to the right. Where's the decimal on that 10? That's right. It's an understood decimal right there. I'm going to move my decimal 3 to the right. 1, 2, 3. That's the same thing as multiplying it by 1,000. So 10 grams is the same as 10,000 milligrams. Now let's go the other direction. Let's say that I have, let's erase this too. 590.2 decigrams. And I want to go to kilo. Again, if I'm doing grams, I'm going to put grams there. Decigrams. To go from deci to kilo, I'm going to go 1, 2, 3, 4. So I've got to move the decimal. This time I'm going to move it to the left. A kilo is much, much larger, so I'm getting smaller as I go from deci to kilo. 1, 2, 3. Uh-oh. I'm going to move one more, and if it's an empty placeholder, I've got to put a 0 in there. So 590.2 decigrams is the same as 0.05902 kilograms. All right, let's practice. Okay, Let's practice. Our first one, 120 millimeters. We're going to start here, get a different color, with milli, and we want to go to centimeters. So we're going to go one to the left. Milli to centa. 120 millimeters, this is our understood decimal. One to the left will be 12.0 centimeters. Okay? Number 2, we're going to start with 6 kilometers and go to meters. 1, 2, 3. So I have to move 3 decimal places. 1, 2, 3. I fill those with zeros. They're placeholders. I get 6,000 meters. 2 centimeters to millimeters. Here's centimeters, right here. Centimeters to millimeters. We're going to just move 1 to the right. 2 centimeters is the same as 20 millimeters. All right, 10 grams. To go from grams to centigrams, grams would be a base unit. 1, 2. So 10, 1, 2 becomes 1,000 centigrams. 7,000 liters to kiloliters. Liters is a base unit. We're going to go 1, 2, 3 to the left. Here's our understood decimal. 1, 2, 3. So 7,000 liters is the same as 7 kiloliters. 5 centimeters to millimeters. Centimeter to milli. We're going 1 to the right. 50. 12,000 grams to kilograms. We're going 1, 2, 3 to the left. 12 kilograms. 11 centimeters to millimeters. 1 to the right. 110 millimeters. 10 kilometers to meters. Here's kilo, kilometers to meters. We're going 3 to the right. 1, 2, 3. 10,000. 10 kilometers, 10K is the same as 10,000 meters. 40 milliliters to centiliters. We're going to go 1 to the left. 40 milliliters is 4 centiliters. 6 meters is going to centimeters. We need to go 2 to the right. 600. 2,000 liters to kiloliters. We need to go 1, 2, 3 to the left because liters 1, 2, 3 to kiloliters. So we end up with 2 kiloliters. Okay? Hopefully that makes sense. We're going to give you a worksheet to try, and then we'll check our work.